Welcome to you from Chem Help ASAP. Let's do a few problems that involve converting line angle structures into Lewis dot structures. Check the video description to find links to the problems in this video as well as a solution set. There will be links during the video that will connect you to other relevant tutorials. Before starting the problems, let's review some ideas. First, in line angle structures, carbon atoms are not labeled. Carbon atoms are understood to sit at the end of all unlabeled bonds. Second, hydrogens on carbon atoms are not shown. CH bonds are not shown, and hydrogens are not included. It's the responsibility of the reader to mentally fill in the number of hydrogens that each carbon needs based on the octet rule. Third, hydrogens on other atoms, oxygen, nitrogen, and sulfur, etc., must be shown. Now that we know the rules for line angle structures, we can practice converting them to Lewis structures. All right, here are our first two problems. We have this structure on the left and a structure on the right. For these structures, I'm going to start by numbering the atoms, the carbons, because it's easy to lose carbons in line angle structures. So for the structure on the right, 1, 2, 3, 4. So we're going to have 4 carbons in this molecule. So there's carbon 1, carbon 2, 3, and 4. We will have 3 hydrogens on carbon 1. So carbon 1 is only shown with this one bond. And so we know that carbon makes 4 bonds, and that tells us how many hydrogens we must have. We need 3 hydrogens to give carbon 4 bonds to have a full octet. For carbon 2 is shown with 2 bonds. Let's give it 2 hydrogens to complete its number of bonds. Carbon 3 needs the same to give it 4 bonds. Carbon 4 on the end only has 1 bond. Let's give it 3 hydrogens, and that is our structure for problem 1. Let's move over to problem 2. Let's number the ends of our bonds, 1 and 2. Those are going to be our carbon atoms. So carbon 1 is attached to carbon 2, and carbon 2 in turn is attached to the oxygen, which has a hydrogen. So let's just now work through these atoms. Carbon 1 only has 1 bond, so we know the undrawn hydrogens must be 3. Carbon 2 only has 2 bonds. We need 2 hydrogens to give it a full octet. Oxygen already has 2 bonds, so oxygen is fine, but oxygen does need a full octet, and we fill oxygen's octet typically with lone pair electrons. So that now has 8 electrons around it, with its typical 2 bonds for oxygen. Okay, here are our next 2 questions, problems 3 and 4. Again, let's number our atoms as we get started. 1, 2, 3, 4, 5. These numbers that I'm putting on this molecule, these are not nomenclature numbers. We're just trying to keep track of atoms. So exactly which atom gets which number is not important. So we'll start with carbon 1. Carbon 1 is attached to carbon 2, then carbon 3, then carbon 4. Now off of carbon 2, we're also going to have carbon 5. And off of carbon 3, we're going to have to take care of the chlorine. Now let's go ahead and let's finish off our molecule and fill in our hydrogens. Carbon 1 only has 1 bond, so we know it needs 4 more bonds. So that's 3 bonds needed to hydrogen. Carbon 2 is shown with 3 bonds. It needs 1 more bond to a hydrogen. Let's take care of carbon 5 while we're over here. It only has 1 bond, so we'll give it 3 to hydrogen. Carbon 3 has 3 bonds. Let's give it 1 more to fill its octet. Give it 1 hydrogen. Carbon 4 needs 3 hydrogens. Now the only atom that's left is our chlorine. Chlorine does not have a full octet as shown. It only has 1 bond. Well, chlorine normally makes 1 bond, and it fills out its octet with lone pairs. Chlorine typically has 3 lone pairs. Let's move on to the next problem, number 4. Number our atoms. Oops, I'm already going to hydrogens. Well, that end atom, that end carbon, carbon 1, will have 3 hydrogens. It's then attached to carbon 2 and attached to carbon 3. Carbon 2 also has 2 bonds to oxygen. Carbon 3 has no more atoms shown in the molecule, so what's left must be hydrogens. It only has 1 bond, so let's give it 3 hydrogens. The last atom is our oxygen. Oxygen normally forms 2 bonds. That's what we show here, but it also is going to need to fill its octet, and we'll do that with 2 lone pairs. And that is structure number 4. Here are the next 2 problems, and what do you know, lucky us, we have to deal with formal charges on these molecules. That's okay though, they're really not any more difficult than molecules that are neutral. So again, as always, let's just number our atoms. For reference, this is a ring molecule, so we'll redraw our carbons in this same sort of ring manner. Carbon 5, carbon 6. Now let's take care of our atoms. So let's start with carbon 1. Carbon 1 has another bond. It has this second bond to carbon 2, so let's draw that in. Now carbon 1 only has 3 bonds. It must therefore have a hydrogen to give it a 4th bond and a full octet. The same is true for carbon 2. It has 3 bonds shown. It needs 4. So there must be a hydrogen there. Now carbon 3. Carbon 3 has a positive charge. And when carbon has a positive charge, that means it's short on electrons. And the only way carbon typically has electrons is through bonds. So that means it's missing a bond. This carbon 3 is short by 1 bond. Well, it's shown with 2. We normally expect 4, so it needs to have 3 bonds. That 3rd bond will be to a hydrogen, and we also need to carry over a formal charge. We can't lose our formal charges. So that is carbon 3. It does not have a full octet, and that's why it has a positive charge. So carbon 4 is shown with 2 bonds. It needs 2 additional bonds, both to hydrogen, to complete its octet. Carbon 5 is in the exact same situation. Give it 2 hydrogens, and carbon 6 needs 2 hydrogens. So that's a bit larger structure, but that's how we can handle a formal charge, specifically a carbocation. Now, let's go to the next structure, carbon 6. Let's number our atoms and draw them going across. There's carbon 1, carbon 2, carbon 3. Note that I am numbering these carbons. Unless your instructor numbers carbons, don't drop the carbons in there. Typically when you draw this, I'm just drawing these numbers in so we can keep track of what we have in our starting structure. But typically when you draw Lewis dot structures, you don't have numbers all over your atoms. So this is for our reference, but when you actually do these problems, if you're turning them in for a grade, you can drop off the numbers. So for carbon 1, it's drawn with 1 bond. We need 4. We need these hydrogens. Before I started talking about numbers, I forgot to take care of the oxygen. The oxygen comes off of carbon 2, and it's right there. So carbon 2 has 3 bonds. It needs 4. That means we need 1 hydrogen. Carbon 3 has 1 bond, so let's give it 3 hydrogens. Now let's address this oxygen, because this oxygen has a formal charge. When oxygen has a negative charge, that means it has too few bonds. Oxygen will almost never go without a full octet, the way carbon did in the structure on the left. So oxygen has a full octet. That means it needs 8 electrons. And that means 3 lone pairs in addition to the bond that we've already shown, and that gives us the full octet. If we were to think about and count through our formal charge, we would find that oxygen now actually has a negative formal charge. So this is the the Lewis dot structure for that particular ion. 2 more problems now. Again, as always, let's number our atoms. 1, 2, 3, 4. So that would be carbon 1. That would be carbon 2. There's our nitrogen in the middle. Carbon 3 and carbon 4. Now let's just go through and add our hydrogens. Carbon needs 3 hydrogens because it only has 1 carbon-carbon bond. Carbon 2 has 2 bonds, so it needs 2 more, 2 hydrogens. The nitrogen, hydrogens are not optional on nitrogen. So the hydrogens are provided for us on nitrogen. We just need to recopy those. Then for carbon 3, It has 2 bonds, so we'll give it 2 more hydrogens to fill that octet. Carbon 4 is going to need 3 hydrogens. Now our formal charge, we're already given our formal charge. We can't add any electrons to nitrogen even if we wanted to because it has a full octet. So this nitrogen is done. We'll just give it its formal charge. Note that nitrogen, when it has too many bonds and keeps its octet, it typically will have a positive charge. And this picture reflects that. Now the structure on the right, another ring. Everybody loves rings, so let's go ahead and draw that. There's carbon 1. We'll kind of recreate this shape. And then the oxygen is connected to both C1 and C4. So carbon 1 has 2 bonds. It needs 2 hydrogens. Carbon 2 is the exact same. Carbon 3 is the exact same. And carbon 4 also needs 2 more CH bonds to fill its octet. So they're not shown in the line angle structure on top, but when we do the Lewis structure, we have to fill in those hydrogens explicitly. Now the oxygen on the bottom has 2 bonds. That's what we look for in an oxygen, but we typically, to fill out the octet, also need 2 lone pairs. So that is that structure, problem 7 and problem 8. Okay, our last 2 problems are now on the screen. Both of them have formal charges, but that's not a problem. We can handle those. So for the left compound, let's number the atoms. Those are carbons 1 and 2. Carbon 1 is attached to carbon 2. And then carbon 2 is also has 2 bonds to 1 oxygen and 1 bond to the other oxygen. Carbon 1 has only 1 bond. So therefore it needs 3 bonds to hydrogen. Carbon 2 has 4 bonds already, so we don't need to add any hydrogens. There are no hidden hydrogens on that carbon. The oxygen at the top has 2 bonds. That's what we expect to see in oxygen, but it needs a full octet and will complete its octet with 2 lone pairs. And the oxygen to the bottom right has only 1 bond. That's not what we expect. To fill its octet, we'll need 3 lone pairs. Oxygen with a full octet and just 1 bond is going to have a negative charge if we were to go through the full formal charge calculation. Now the structure on the far right, let's number these unlabeled atoms because we know those are carbons. So here's carbon 1. Carbon 1 is attached to an oxygen. Then it goes to carbon 2 and carbon 3. Carbon 2 is also attached to an oxygen, and carbon 2 and 3 have a double bond. So let's finish off our hydrogens and our electrons. Carbon 1 has 1 bond. As we know, it needs 3 more hydrogens. The oxygen has 2 bonds, which is what we'd expect, but for a neutral oxygen, we're going to need to fill out its octet and give it 2 lone pairs. The top oxygen, or let's do carbon 2 first. Carbon 2 already has 4 bonds. That's why I kind of skipped it. But it has 4 bonds, therefore there are no additional hydrogens that we need to add to carbon 2. The oxygen at the top has 1 bond. It's going to have a full octet. Very rare for oxygen not to have a full octet. And so that would mean it has 8 electrons in its valence shell. When oxygen has a full valence shell and only 1 bond, it's going to have a negative formal charge, which we already knew based on the structure at the top. Finally, carbon 3. Carbon 3 has 2 bonds to 1 back to carbon 2. Therefore, it needs 2 more bonds. And those bonds are 2 hydrogens. And so that completes this problem set. I hope this video was helpful for you. Please subscribe, like, or leave a comment or question. Links to downloadable copies of these problems and solutions are in the video description. Thank you for watching.